Okay, let's dive into this. Have you ever felt like math has its own secret language? Well, today, we're going to crack one of its most useful codes, HCF and LCM. Now, they might sound a little intimidating, but trust me, they're just really clever tools for understanding how numbers work together. Right? You've probably seen these letters pop up in math class and thought, okay, but what do they actually do? They can seem pretty abstract, but they are hiding in plain sight all around us. And by the end of this, you'll see them not as some weird puzzle, but as a key. So here's our game plan for this decoding mission. We'll start with the absolute basics, the building blocks, factors, and multiples. Then we'll shine a spotlight on both HCF and LCM, see how they show up in the real world, and then we'll uncover a final, really cool secret connection between them.
All right, mission accepted. Every good number code is built from two key ideas, factors and multiples. Let's start by breaking down the first one.
So let's zoom in on that F in HCF. It stands for factors, and these are basically the DNA of any number. They are its essential building blocks.
So what exactly is a factor? It's actually super simple. Think of them as numbers that can be multiplied together to perfectly create a bigger number. You know, like how 2 and 5 are factors of 10, because 2 times 5 gets you exactly 10. No messy leftovers or remainders.
Okay, so how do we find all of them without missing any? We just use a system. Let's take the number 12. We always start with the easy pair, 1 and 12. Then we check the next number up, 2. Does it work? Yep, 2 times 6. How about 3? For sure, 3 times 4. Now, because 3 and 4 are right next to each other, we know we're done. Same thing for 18. We get 1 and 18, 2 and 9, and 3 and 6. See? Simple as that. So now we have our two complete lists of factors. To get to the C in HCF, which stands for common, we just look for the numbers that they share. In this case, that's 1, 2, 3, and 6. And for the H, highest, we just pick the biggest number from that shared list. And that's 6. So the highest common factor of 12 and 18 is 6. It's the biggest number that can divide both of them perfectly. So we've cracked the HCF code by breaking numbers down, and that HCF of 6 is actually useful. Imagine you have 12 roses and 18 tulips. That HCF of 6 tells you that you can make a maximum of 6 identical bouquets. Pretty cool, right? Now let's switch gears and decode the M in LCM, which is all about building numbers up. A multiple is just what you get when you take a number and, well, multiply it. So the multiples of 3 are just 3 times 1, which is 3, then 3 times 2, which is 6, then 3 times 3, which is 9, and on and on. It's literally just a numbers times table. Okay, so we've got factors for breaking numbers down and multiples for building them up. But the real magic, the interesting stuff, happens when we start comparing different numbers to find out what they have in common. This is where their individual paths finally cross. Here is an absolutely fantastic exam tip. Anytime you see the word common in math, just swap it out in your head for the word shared. It's such a simple trick, but it makes everything click. We're just looking for the numbers that different lists of multiples share. Let's put this idea into practice with a real example. We're going to find the shared multiples for 3 different numbers, 3, 4, and 6. And the very first step is to just write out a little bit of the times table for each one. All right, first up, let's list some multiples of 3. We've got 3, 6, 9, 12, 15, 18, 21, 24, and it just keeps going. Next up, let's do the same for 4. That gives us 4, 8, 12, 16, 20, 24. Keep an eye out for any numbers you've seen before. And finally, for the number 6, we've got 6, 12, 18, 24, and so on. Okay, now we have our 3 lists ready to compare. Now this is where it gets really interesting. When you line up all the lists like this, you can just scan across and see which numbers pop up in all 3 rows. What jumps out at you? Exactly, the very first number they all share is 12. And if you look further down the line, the next one is 24. And if we kept our lists going, the next one would be 36. These are our common or shared multiples. So we found this list of shared numbers, 12, 24, 36, and it goes on forever. But in math, we often want the most efficient answer, the most fundamental one. And this brings us to the final piece of our code, the LCM, the least common multiple. So we have this infinite list, right? 12, 24, 36, and on and on. They're all correct. They're all shared. But is there one that's a little more special than the others? Which one really holds the key?
Well, the name kind of gives it away, doesn't it? The least common multiple. It's simply the smallest, the very first number that all of our original numbers can build up to. It's their first point of agreement.
And for our example, that number is 12. Out of all the common multiples, 12 is the smallest, the least. That's our LCM. So why is this useful? Well, imagine 3 runners on a track. One takes 3 minutes to run a lap, another takes 4, and the third takes 6. The LCM of 12 tells us that they will all cross the starting line together at exactly the 12-minute mark. And now for the final secret of the code. It turns out HCF and LCM aren't just separate tools. They have this hidden connection. For any two numbers, if you multiply their HCF by their LCM, you get the exact same answer as multiplying the two original numbers together. Let's check with our first example. The HCF of 12 and 18 was 6. Their LCM is 36. What's 6 times 36? It's 216. And what's 12 times 18? It's also 216. It's a perfect check every single time. So we've cracked the code. HCF helps us break things down into the largest shared groups, like making bouquets, and LCM helps us find the next time different cycles will sync up perfectly, like our runners on a track. Both are about finding what numbers have in common, just from completely different directions. Finding common ground. Where else in life is that a powerful idea? Something to think about.